Thank you very much for inviting me to speak, and thank you to the organizers for still organizing this. This is an amazing job on this time frame to do it. I'm really full of awe here. And I'm going to talk about considerations when deciding Leptospermum honey production areas. And my presentation is together with Abrão Santos, who is at the University Federal de Viçosa in Brazil, and who has contributed greatly when he was here for a year as a PhD student. Something's not working. Let's see. Okay, so when we design foraging sites to support bioactive monofloral honey, we need to think about where to situate the site, what species of Leptospermum or other plants we use where, do we irrigate or something like that, and can we improve the health of these monofloral sites for bees? And that's what I'm going to talk about. First of all, where should we best create monofloral hive sites? Well, if you do it in biodiverse areas, chances are that your crop will flower at the same time as some eucalypts are flowering, which is a real issue because eucalypts happen to be very attractive, and especially when it's Leptospermum, often the eucalypts can outcompete or very much compete for the attention of the hive and for honey production, and that will reduce, of course, the bioactivity of your honey. So biodiverse or conservation areas are not ideal. Clearing to plant monoculture, I think we all agree that we're past that. We need what we have left in conservation areas and native areas and shouldn't be replacing that with a monoculture. So where do we plant? Well, use cleared land in degraded areas. Your monofloral honey is guaranteed and your environmental impact is generally positive because you're adding a native plant to an area that hasn't got anything. Good. So one of these areas is, of course, almond orchards. Exclusion zones in almond orchards are really interesting sites. So exclusion sites you see in this photo, one in the middle, where almonds cannot be grown. Why not? Well, very often because the area is too wet. And we all know that most Leptospermum species actually like wet feed. Now we should make sure that it's not too saline either, but when it's wet and not too saline, that is possibly where these sites can be made. And it's not only almond orchards, of course, but almond orchards have a great benefit to them. First of all, almond growers are set up to take care of orchards. Beekeepers are often not. And they have the irrigation in place, which is a lovely thing to have because that is costly. Almond growers are also motivated. They need to keep good rapport with the beekeepers to get their almonds pollinated on time. And they are also very much aware of their environmental impact, as every almond kernel costs about 5 liters of water to produce, and Leptospermum sites cost a lot less. So they also are cashed up still. So the combination of Leptospermum production and almond production could well be very advantageous to both if business model, and that's what we're working on, is made to share the profits from that. So then what species of Leptospermum could go where? And this Abrão, when he came, he was used to climate modeling with Maxent. And I asked him, well, can we look at a number of bioactive Leptospermum species and look at where they can be grown, where the conditions are favorable for them. And so this is current distribution, so not taking into account climate change. And with the current distribution, what the input is into the MapCent modeling is the current distribution and soil and climate attributes. That is what Abrao put in there. And the output is then the potential distribution, but also the factors that correlate most with the occurrence, and that can inform, for instance, the need to irrigate. And the 7 species that Abrao used were Lanigerum, nitens, Polygallifolium, Scoparium, Liversidgei, Speciosum, and White-eye. So a range of species. I know they probably belong to different groups. I know that since yesterday, since Margaret's talk, but this is what we used. And what Abrao found was, you see the input there from occurrence records that was all manipulated to not have big overlaps, so not to have autocorrelations and things like that in there influencing the data. And then the output is a suitability area, which is different for different species. When you look at nitens, it's got a more arid distribution, as we know. Lanigerum would be suitable to grow in southeast Western Australia, southwest Western Australia, and Polygallifolium isn't really suited to Tasmania. So that's the kind of information that we get. Scoparium is very much distributed to the south and good for Tasmania. So with the 3 species that were from the east coast, what we see is that they are really, really east coastal. And as far as I'm concerned, this is a worry. There is some caveats here. Of course, the distribution of Leptospermum is often in gullies where there is water. And so that detail in distribution cannot be incorporated in the model. You need to have much more detailed modeling than that to get that sort of detail in there. But this is what came out of the model. So I'm a bit afraid that with increasing droughts, some of these species might actually fall off the map. But we didn't model that. So here what you see is how the different variables that Abrao put into the model contributed to the variation in distribution. And what we see that aridity has a major influence for Liversidgei, Polygallifolium, Speciosum, and White-eye, and that aridity index is actually, they don't like arid zones. So it has got a big influence, but it's a negative influence. For Lanigerum and Scoparium, what we see is another factor related to water, evapotranspiration during the hottest month. That is what these species are most influenced by in their distribution. And nitens, of course, is fairly different and is influenced by clay content, which it doesn't like, and degrees, days above 5, which is probably why it doesn't occur in Tasmania or cannot occur in Tasmania. So this gives a small overview. It's not a complete overview, but a small overview where you can also deduce that because drought isn't liked and aridity isn't liked by these species, irrigation is probably an issue and needs to be achieved. Now, there is another reason why irrigation is very important. We had, if you remember from yesterday, Kate Delaporte talking about our plantations of Spring Gully in Wirrabra Forest. And in that, we have rows that are irrigated very often and that are irrigated a lot less. And There's no big difference in growth between the rows. There was no big difference in flowering between the rows. But when you look at the visitation, which I like to do because I like to know, well, what do the bees think about this? So what you then see is that the bee visitation to irrigated plants was 3 to 4 times higher than the bee visitation to non or less irrigated plants. And that is really important because that reflects how much honey you would get from them. Now, we don't know how irrigation influences DHA, and we're going to find out. But I think this is really very important information for the industry, that you get more honey or more visitation when you irrigate. Okay, so Leptospermum, it's a lovely plant, but bees collect only pollen, nectar from it. They do not collect pollen. I've never seen them do it. So I've seen some native bees, very few collecting pollen from it, but not honeybees. And so to make a healthy hive site with a monofloral plantation, that is a difficult thing to do, of course. You want other plants in there that do provide the pollen, or you need to feed pollen patties all the time. And I've talked to beekeepers who actually say that, yes, well, if I put my hives into a leptospermum plantation, they get knocked a bit because they get no pollen in. And so my fourth question was, well, can we then provide some pollen plants for bees at these sites? And I've explored a number of plants. Of course, my preference is to go for native plants because native plants are also food for many native bees, which I like. So pollen-only native plants are various, but some of them are not very well liked by honeybees, such as Wallenbergia, and but others really are. And of those others, plants can be selected that flower together with Leptospermum species. As we know, Leptospermum species flower at different times. And in Warabra forest, there was a beautiful stand of Cassinia next to our plantation, and the bees were collecting pollen from that and no nectar. So that would be a really nice complementary plant in that case. Other possibilities are crops. Now, some crops and also some non-native plants like flowering wind-pollinated trees flower very early in the season when generally leptospermums are not flowering, but a crop such as olive flowers in late spring, and you could select your variety of leptospermum and olives to be grown together and then have the benefits of olive pollination, which are there, plus also the benefits for the bees, which really like olive pollen and are really active on olive. So non-natives, I'm not in favor of them, but there are various non-natives that can be planted to or promoted together with leptospermum, but I wouldn't do it really, it's not worthwhile. So you'd have to select them to coincide with the flowering species. And so that's where we're at now. Situate monofloral hive sites in Degradia. So the species, well, if you choose something that's already likely to grow, you'll probably have more success, but irrigation is needed, and irrigation also enhances bee visitation, and pollen-only plants can be selected to coincide with leptospermum flowering. And that's basically what I had to present. So I'm happy to take questions. Thanks. And thank you. And thank you to Spring Gully Foods and Nick Timms, who collected the data on the visitation, Georgiana Parrish, who assisted me in selecting pollen-only plants, Kate Delaporte, who is a source of inspiration, and Liz for organizing all of this. Wonderful. Thank you.